In this video, I will show you how to solve exponential equations such as these. Now, before we dive into that, a little bit of background information that we're going to need to solve this problem. Remember that when you multiply variables with exponents, for example, if I have n to the third power times n to the fifth power, what's that going to be? That's going to be n to the eighth power because you add the exponents. So let's apply that to this problem. If I want to multiply these two expressions together, they have those like bases. So again, I'm going to keep the like bases, but I need to add these exponents. So I need to do the 2x plus 5 plus negative 8. Now, so I'm going to get 2x, but the like terms are the 5 and the negative 8. So I'm adding 5 and negative 8, and that's going to make negative 3. So this is what you get when you keep the like base and you add these exponents. Okay? So now, to solve an exponential equation, we're going to need to rewrite this in log form. And the way you do that, log form will obviously start with log, and then you put the base. So the base here is 7. All right, and then the exponents, basically what's going to happen is these two things are going to switch places. Okay, so the 12 is going to end up over here, and the 2x minus 3 is going to end up over there. So now we can get x by itself using our algebra skills. So for example, we will add 3 to both sides. Okay, so now I have log base 7 of 12 plus 3 is equal to 2x. And then finally, to get x by itself, I'm going to divide both sides by 2. All right, just go ahead and just put 2 under a big old fraction like that. So this is going to give us the answer. So now it's just a matter of how will I type this into my calculator. Now, focus on this part right here, log base 7 of 12. We can use the change of base formula to rewrite that as log 12 over log 7. All right, so this has now been written like this. So now we still have the rest of it. Okay, we still have the plus 3, and the whole thing is divided by 2. So this is how we will type it into the calculator. So I see I have a fraction inside of a fraction. So let's go ahead and hit the fraction button. Now what I recommend to you is go ahead and put the denominator in first. See the 2? So I'm going to go ahead and jump down and put in that 2. So now back to the numerator, I have this fraction plus 3. So I'm going to hit my fraction button again, and that fraction is log 12 over log 7. So I can just go ahead and type log 12 over log 7. You know what? OCD demands that I close these parentheses. Now don't forget, off to the right hand side, still in the numerator, we need the plus 3. And there it is. We have typed this entire expression into the calculator, so now we can evaluate. Now we're supposed to round to the nearest thousandth, so that means 3 decimal places. So this is 2.138. So x is equal to 2.138. All right, and that's it for example 1. Now, example 2 is going to be very similar, but now we have division. So again, let's remember how we divide variables and their exponents. Let's say if I had n to the 12th power divided by n to the 3rd power. Okay, do you think that this would be n to the 4th power because 12 divided by 3 is 4? Well, you'd be wrong if that's what you thought. This is going to be n to the 9th power, because the way you do this is you keep your base and then you subtract. So you do 12 minus 3. And so that's why this is going to be n to the 9th power. So applying that to example 2, okay, we need to be ready to subtract. So I'm going to keep my base, but I need to do negative 5x minus 3x. All right, I subtract these, is equal to 18. So that's going to give me 4 to the negative 8x power is equal to 18. Let's go ahead and rewrite this in log form. So start by writing log and the base. Okay, now these two parts switch sides. So the 18 is going to come over here, and the negative 8x is going to go over there. Now to get x by itself, all we need to do is divide both sides by negative 8. So just put negative 8 underneath all of this. Now, to put this into your calculator, you will need to rewrite this part using the change of base formula. So log base 4 of 18 can be written as log 18 over log 4. Okay, that's just this yellow part. Now, so that's supposed to be all divided by negative 8. And this will give us x, all right, because these are gone now. So now it's just a matter of typing this into your calculator. So we have a fraction happening. I suggest putting in the denominator first. See that negative 8? So that negative 8 is going to go right here, negative 8, and then go back to the numerator. And here we have a new fraction. So hit your fraction button again, and what we have is log 18 over log 4. So you can go ahead and type log 18 over log 4. All right, and evaluate that, and we have negative 0.261. Let's go ahead and round that last one up. All right, so there is your answer to example 2. Go ahead and pause the video here and try to do problem number 1 by yourself. Okay, let's go ahead and do problem number 1 and see how we did. Again, when you are multiplying these expressions, you keep your like base and you add these exponents. So I'm adding x plus 1 and x minus 1. So basically I'm doing this, x plus 1 plus x minus 1 is equal to 10. So combining my like terms, that's going to give me 3 to the 2x. Oh, look, the plus 1 and the minus 1 cancel each other out. So I just have 3 to the 2x is equal to 10. Time to rewrite this in log form in order to free this exponent. So log form, we start with log and the base, and then these two switch sides of the equation. So the 10 is going to end up over here, and the 2x is going to end up over there. Then all you really need to do is divide both sides by 2 in order to get x by itself. However, in order to put this in your calculator, we will have to use our change of base formula to sort of rewrite this part. So log base 3 of 10 can be written as log 10 over log 3. Now all of that is supposed to be divided by 2. All right, so that is going to give us the answer. So in our calculator, we will start with our fraction. The denominator is 2. I recommend always putting your denominator in first. And then back in the numerator, we have another fraction. So now I'll put another fraction in the numerator, and that is log 10 over log 3. So I can do log 10 over log 3. So 1.048, got to round up. All right, so that is how you do problem number 1. All right, go ahead and pause the video here and try to do problem number 2 by yourself. Okay, so problem number 2, this problem is different. We don't have 2 bases, we just have this one base. So we can go ahead and start trying to isolate this part of the equation that has the x in it. So we definitely want to add 5 to both sides. So that is going to give us 1/2 to the x plus 4 power is equal to 35. Now 1/2 is the same thing as 2 to the negative 1 power. You know how n to the negative 1 power is 1 over n? Well, same thing here. 1/2 is the same thing as 2 to the negative 1 power. But then we've got this x plus 4, which would go right here. All right, so then a little distributive property, and you have 2 to the negative x minus 4 power is equal to 35. And then now it's time to rewrite this in log form. For log form, you start by writing log, and then the base, so log base 2. Now this part of the problem and this part of the problem are going to switch sides. So I'm going to have my 35 will be here, and my negative x minus 4 will be here. Now we have log form. So now we can keep going to get the x by itself. So we will need to get rid of the negative 4 by adding 4 to both sides. So now I have log base 2 of 35 plus 4 is equal to negative x. All right, we need just a regular x, not a negative x, so we can get rid of that negative sign by dividing by negative 1. So we're going to have to divide both sides of the equation by negative 1. All right, so now when you divide by negative 1, it just changes the sign. So that just means I'm going to have negative log base 2 of 35 minus 4 is equal to x. Now don't forget, so log base 2 of 35. So this part of the equation, I will have to use my change of base formula to sort of rewrite that. So this would be the same thing as log 35 over log 2. And we still have that negative sign there. And so we have that minus 4, and that should give us x. So we're just going to put this in the calculator. So we have the negative sign and then fraction. So now it's time for log 35 over log 2. So log 35 over log 2. And then minus 4. Boom. Negative 9.129. All right, so that is the answer to number 2. Go ahead and pause the video here and try to do number 3 by yourself. Okay, so problem number 3. So we have a division problem. So remember, when you do division, what you need to do is subtract the exponent parts. So I'm going to keep my like base, but then I need to do 4x minus x minus 1. Whoops. Now be very careful here. See how I put the x minus 1 in parentheses? That's important. This negative sign needs to be distributed through this. All right? So I'm going to have 10, and then I have this 4x. But now watch this. I have minus x plus 1. So that's the most common mistake, is students forget that this subtraction, this negative sign, must be distributed, which will cause this minus 1 to become plus 1. So now, combining like terms, 4x minus x is 3x. So I've got 3x plus 1 is equal to 55. So now it's time to rewrite this in log form. So we write log, and then the base, which is 10. And then these parts switch sides. All right, the 55 and the 3x plus 1. So I have 55, and that is 3x plus 1. Now this is a little bit of a special case because log base 10 of anything, the 10 is to be understood. So we don't have to put the 10. So we would really just put log 55 is equal to 3x plus 1. When it's a 10, you don't put the 10. All right, so now we can keep going to try to get x by itself. So I would subtract 1 from both sides. So now I have log 55 minus 1 is equal to 3x. By the way, please don't try to subtract the 1 and put log 54. Can't do that. So now we just need to divide both sides by 3. So divide by 3, divide by 3. And that will leave x by itself. All right, so we're just putting this in the calculator. So we need our fraction, and then we divide it by 3. So I have log 55 minus 1. No need for the change of base formula. So I can just do log 55. Whoops. Forgot to go up to the numerator. So I can just put log 55 minus 1. Just like that. Boom. So I have 0.247. Got to round up. And that's it. That is the answer for number 3.